So now here you can say the try or wire both are equivalent only. So here how this the table, the let type and the resolution functions are written here. So if both are equal, that means if both are zero, you can see here. If both are zero, then it is zero. So both are one, the inputs are one means it will be high only. If any one is low, you can see that any one is unknown. If any one input is unknown, you can see complete unknown we get. If any one is Z, like input Z0 means I am getting 0, then 0. Okay, so when you are having 0 and 1, you can see when you are having 0 and 1 also it will be X, because initially we seen, I hope you might have remember. So two unequal strength value 0 and 1 output will be X. So 0X also is X only. Then 0 Z, if any one value is high impedance, then the output will be low, that is 0. See here, if both are high impedance, Z in the sense, even also will get X. So normally here in this table you will see inside here for this function tri-state or wire. Tri-state meaning is what? The output it will provide only three states of output with 0, 1, Z. Those three only. Next here AND gate, NAND gate if you see the output as well as the input will be in four states 0, 1. So try NAND or W AND. So W AND means wired AND. It perform a AND operation. So the four inputs 0, 1 XZ, 0, 1 XZ. 4 combination. This is the, I can say it's called as a truth table also for 4 inputs. That means 4 possible combination inputs. This is wired R. So like this, different tables are there. You can refer these tables. See, there one of the example here for this module W and underscore test same wired and test output I1, I2. Here we declare the input as I1, I2. The output is out there. Then one more we given us the output out is W and out. Now we return the statement assign out is equal to I1, assign out is equal to I2, end model. Now can you say what kind of operation it will perform, because here I am not specified the assign out is equal to what operation it has to perform. But by default you should understand that here we return W and out, that is wire and out. The out is here wire of W and in the sense. So if you say assign out is I1 is assigned, then I2 also is assigned, then I can say simple out is equal to I1 and I2. That is what is simple, very simple you can say here. I'll write us like this, out is equal to I1 and I2. This is the meaning of this. This is the meaning of this actually. Okay. Same here for R. What will be this? Same, even this also. Out is equal to in 1 or in 2. This is the meaning of this. So because we used the WR. So no need to write here out is the in 1 or in 2. This is the another way. Next, the data type is variable data type. The variable data types are integers. Variable data types are integer, real, real time, reg time. These are the keywords. These all are keywords used as a variable data type actually. First, let us study about the registers. Normally, the registers represents data storage element. Here, the register will be retain the value until another value is placed. Because normally the register will hold some value when that value will be replaced. When you are going to save some new value on the register, the old value will be replaced. That is what we can say. So you should not confuse the term registers in Verilog with hardware registers built from edge-triggered flip-flops in real circuits. Don't get the confusion that REG we'll write in our Verilog REG. That is not this actually. Both that one is REG is a keyword actually. Don't confuse with the flip-flop registers. That is what we say here. In Verilog, the term register means the variable that can hold a value. That is the meaning of here. That is by simple I can say the keyword as REG. Unlike a net, because normally the net or wire will not store the or will not hold the value, but the register will hold the value. So net, a register does not need a driver. See, unlike a net, a register does not need a driver. For only for wire we need a driver, but for a reg no need. Driver is not required. The Verilog register do not need a clock. The Verilog register doesn't require the clock as hardware registers do. Normally, when you go for any hardware register, in the sense simple, which is hardware register? That is simple flip-flop, I can say. That is required a clock actually. But the Verilog register, the RAGs, doesn't require clock. The value of registers can be changed anytime in a simulation by assigning a new value to the register. So the register, when you are assigning some value, that value you can change in a simulation by assigning a new value to the register. You can change anytime actually. That is a variable. That is what I'm saying, it's a variable. You can change anytime. The register data types are commonly declared by the keyword reg. See, this is what earlier. So the register data type commonly declared by the keyword which will use is reg. The default value of reg, the type is x. What is the default value of y? That is net. What is the default value for net? Do you remember the default value of net? The default value of net is Z, high impedance. The default value of register is X actually. Now the examples for register here you can see. The examples for registers are reg, reg, reset. The reg is a keyword actually. This is the register name reset. So we are going to declare a variable as reset that can hold its value actually. So next I written initial, this construct let us see begin reset equal to 1, that is 1 dash b1, that is we initialize the reset is equal to 1 hash 100. This already we know. That is meaning is what? After 100 time units. That is the meaning of that. After 100 time units, the reset is become as 0 actually. Until reset will be 1. That is the difference here. You can see that example for register. These are the declarations. You can go through the notes. Different declarations are there. Some extra things I given in the material. Actually, you can go through these things and all. Next, registers can also be declared as signed variables. See, the signed variables such registers can be used for signed arithmetic. In the sense, when you are going to perform a arithmetic operation, signed arithmetic means signed addition, signed multiplier, all those things. So we can use the registers also. The register REG is by default a 1-bit unsigned value. See, very important. Now, by default, the register is an unsigned value. At the same time, it is a scalar value. It's a 1-bit value actually. So here, if you want to use a signed value, that is something about what? The negative number, if you want to use in the register, or if you want to store a negative number in a register, then you have to use like this REG followed by signed. The signed also is a keyword. Reg space signed 63:0 M. What is the meaning of here? Meaning is the M is a register that has or it holds 64-bit signed value. That is the meaning of that. Reg signed 63:0 M means what? M is a register that holds a 64-bit signed number. Then integer I, it is a 32-bit signed value. Normally, the integer we have both the positive and the negative value. Normally, a positive and negative value. So only we said integer I, you can say. See, another example is reg A. See, it's a register, it's a scalar actually because we're not supposed to any vector. W and W. It's a scalar net of type W and. Now you can see this is the vector type of register. edge 3 colon C V. V is a register variable. So V is, it will hold a 4-bit value. That is the meaning of the converse. Like already we studied, that is 3 colon 0 means what? V of 3, V of 2, V of 1, V of 0. That is the meaning of that. Next, try. You see that try 15 colon 0 bus A. It is nothing but what? It is a tri-state 16-bit bus actually. Yeah, tri-state 16-bit bus. Tri-state in the sense 3 state 0, 1, etc. Then register 1 colon 4 B. The B is a register. It holds how many value? 4-bit value because 1 to 4. That is 4-bit vector register. That is B of 1, B of 2, B of 3, B of 4. That is what you can say here. Next, tri-reg is small storage. So here it is a charge storage node of strength is small. This and all we are not going to use. Normally, these are the some commonly used the registered terms actually. Next, vectors. Now in this vectors here, next are registered data types can be declared as a vector actually, right? Because as I said, you can declare the net or register in a scalar or vector also you can declare. So here vector represents what? Multiple bit width. If bit width is not specified, then the default is scalar only. It will be considered. If you not specified the bit width, then it will be considered as scalar only. The examples are vectors are like this. See, wire A. It's a scalar value by default actually. Wire 7 colon 0 bus. This is already we studied. You know that 7 colon 0 bus means it's a 8-bit bus actually. Wire 31 colon 0 bus A, bus B, bus C. There's something but 32-bit bus A, bus B, bus C. All the three buses are 32 bits. Next, register clock. It is a scalar. Next, register 0 colon 40 virtual address. That is nothing but what? It's a vector register. The virtual address is 41 bit wide because 0 colon 40 means 41 bit wide. So here this vector can be declared hat like this. Like here, as I said, it's a high. This is low. Or low as colon high. That is nothing but 3 colon 0 or 0 colon 3. That's why earlier I said it's MSB, it will become as LSB. It's LSB, MSB. Like the only thing is the position will get changed. That's it. But the left number in the square bracket is always the most significant bit of vector. See, that is what I said. The example shown above, bit 0 is the most significant bit of virtual address. So this is the very important thing in the Verilog. Still now, do you have any doubt? Okay, this is all about the today's class. Let's continue in the next class actually. Just till now, whatever we studied, go through daily, study the daily portions, else it will be feel very difficult. Thank you for everyone.